This is a tracing table that shows you the client point of view and the implementer point of view when adding elements to the end of the list. Now, we're not using arrows for the next and previous links anymore, but this approach works just fine, and I just wanted to show you that you can reason using this type of diagram. Okay, that's all for the main concepts of the linked list implementation. This is code that fills out the linked list implementation that we started previously. Now, I won't spend a lot of time on the code, but there are a few things to notice here. First, notice that the add methods call through to a private helper method named addBefore. The addBefore method takes an element and it also takes a node object. It's called when you want to add the element just before a specific node. Now, this list linked implementation you see here, just like Java's list linked implementation, has quite a few helper methods. Any method that takes a node or returns a node has to be a helper method because node is a private inner class that cannot be seen from outside the implementation. Another helper method used here is the node method. The node method takes a list index and returns a handle to the node that corresponds to that index. You see it here in the else portion of the second add method that adds an element at a specific index. The remove method is also just a call through to a private remove method that takes a node. The get method simply calls the node method and returns a handle to that node's element. The set method replaces the element in the appropriate node and returns the original element. And the indexOf method returns the index of the element if it exists in the list, or -1 if it does not. Here are some of the helper methods where much of the work is done. The addBefore method uses the assignment statements we saw in the last pause and think slide to update the links of its previous and next nodes. Both the addBefore and the remove method here do similar things to what we saw when we discussed adding and removing elements from a specific index. The exception is that the first step, finding the node at the specific index, has already been accomplished by the time we reach these helper methods. The parameter n here that you see in these methods serves the same function as the temporary variables that we used in our pause and think slides. And finally, this is the helper method that accomplishes the first step of finding the node that corresponds to a particular index. After checking that the index is valid, we see if it's more efficient to use the next links or the previous links, and then we iterate through the nodes until we find the one we're looking for. And that's it. I hope you found this module interesting. The implementation of linked data structures can be quite challenging at times, but it's an essential tool to understanding how a language works.